Email now is one of the most important online services that we use. For most people, it can be a single point of security failure because many of our accounts are linked to it. If you have an email compromise, your associated accounts are also compromised. Private information will be compromised, including your name, address, contacts, friends, and anything else that's associated or stored within your email. It's obvious to most people while email security is important, but email, unfortunately, is fundamentally broken as far as security is concerned, and it cannot be fixed. All we can do is keep putting sticky plasters on it, plasters which, unless everyone else adopts, which is pretty much the same as changing email completely, we're just not going to fix these security problems that are inherent in email. Email is from a time when security wasn't thought of, but we continue to use email because it is ubiquitous. Everybody has an email address now. If everyone suddenly switched to a secure messaging alternative tomorrow, the problem would be solved. But because that's not going to happen, we are stuck with a broken messaging system called email. This means you will need to convince others to adopt encryption technology if you want to communicate with them privately. You can't do it on your own. Let's take it from the beginning. So there are two ways to access email. First, you've got your web browser using functionality like HTML5 and JavaScript. And probably most people now think of that as email. That is the most common way that people tend to access email, via Gmail or Yahoo Mail. But the second way that is used is an email client, which is something like Thunderbird or Clause or Outlook people might use commonly at work. You have Mac Mail, or you have the mail apps that you get on your cell and mobile phones. Those are all email clients. And most email providers will allow you to use both methods, the webmail access and the email client. With webmail, you access via HTTPS port 443, which is running SSL and TLS encryption, or at least you should be. That is the standard solution for most people. If you're not, then it's extremely insecure. But really, almost all webmail will be encrypted using HTTPS port 443, SSL, TLS. You authenticate that the server is genuine, via a certificate, as is normal with HTTPS, and the client is authenticated, usually with a password. And if you can, you should change the authentication method to be two-factor authentication, as this mitigates password attacks, as we've discussed in the password section. You should find an email provider that offers two-factor authentication. If you only use webmail, then emails are only stored on the server. And then we have the email client. With an email client, there are a number of protocols and port options for both sending and receiving email. So the options when it comes to receiving mail is you have IMAP port 143, which is unencrypted. You have POP port 110, which is unencrypted. You don't want to use these. If you care anything about your email security, receiving emails, then you don't want to use these. And most providers now either don't provide them or provide encrypted alternatives. And those alternatives are IMAP port 993, which is running SSL TLS encryption with the certificate-based server-side authentication, like with a website. And you have POP3 on port 995, running the same SSL TLS encryption with, again, certificate-based server-side authentication. And those are the two that you want to go after for receiving email. IMAP port 993 and POP3 port 995. Now, some email providers may put those on different ports, but those are the de facto port numbers. But what is important is that they're both running SSL and TLS. Now, when it comes to the difference between IMAP and POP, of the two, IMAP is the popular option when you need to check your emails from multiple devices, such as a laptop, phone, tablet, and so on, because the emails are synced using IMAP with the server and all devices. All devices retain copies with the server having the master copy. This is the most convenient and what most people will be used to using. POP3, alternatively, downloads emails from the server to a single email client, then deletes the emails from the server. Because your messages get downloaded to a single email client and then deleted from the server, it can appear that the mail is missing or disappeared from your inbox if you try to check your mail from a different email client or webmail. But you may want this for security though, to have no emails stored on the server. If you're worried about people accessing the server, use POP3. If you're worried about people accessing your laptop, store on the server and the client with IMAP. Then we have the protocols for sending emails with an email client. We have SMTP port 25, which is the original unencrypted port to use. You don't want to use this if you care about your emails and sending your emails and privacy. Then you have something called Start TLS, which is usually on port 587, and that is using SSL TLS encryption. And then you have SMTP port 465, which again is SSL TLS encrypted. You want to use, where possible, SMTP port 465 with the SSL TLS. Start TLS on 587 is more susceptible to man-in-the-middle attacks. So go with the SMTP port 465 SSL TLS option. For both email clients and webmail, the SSL TLS will use a cipher suite, obviously. You want this to be a good one, ideally using elliptical curve Diffie-Hellman, so that the session keys are ephemeral, so that if the private key is compromised, only small amounts of data is compromised. The section on encryption covers this. If you remember back to when we looked at cipher suites, we use a tool called SSL Labs, which is here. This doesn't scan SMTP or IMAP SSL mail ports, unfortunately, but you can use it for checking port 443 for webmail. So for example here, I could check Ghostmail and see how their SSL TLS stacks up. And here we go, A+. There we see elliptical curve, RSA with AES, so yeah, they seem to be doing all the right things there. Now if you want to examine the other ports like 465, 587, you've got a few options for how you can do that. One with Kali is you have SSL scan. And if you press return here, that's just going to simply do port 443. But if you want to do a special port, you would do 465. So then you could look at the SMTP over TLS SSL. Just press return here. You can look at there, because Ghostmail only has a webmail interface. But if they did have port 465 open, you could check that out. So here we see what we saw with SSL Labs, the same cipher suites. Another way of checking out the mail servers, which I like, is these guys here. So if we put in an email address of someone that you know and we click try, or if you put in even a dummy email address, if you put test at Ghostmail or Gmail or whatever, you click try, it communicates with the mail servers. It finds out who the mail server is for that domain, because it isn't always ghostmail.com or that domain. So you can see here we have the mail server there. That is taken from what's called the MX record for that domain. MX is the mail record or mail exchange record. And what you can see here is the communication with the mail server. You can see there this is using Start TLS. And there we can see the cipher suite that it uses. And what you're actually seeing here is text, ASCII communication with that port. So these commands are actually being put into the packet stream for that port. In fact, I can show you an example of that. So let's check out maybe Gmail. So first of all, we need to figure out what the mail server address is. So we need to use something called NSLookup. So this is doing a DNS lookup to check the mail exchanger record, which will give us the IP address of the mail server for gmail.com. And there we go, and we can see actually they've got quite a few, which is no surprise. So to issue text-based SMTP commands, we need to use some sort of tool that will allow us to do that. We can use Telnet, or we can use Netcat. Netcat is a tool that enables you to read and write to network connections using TCP and UDP. So if I go... So as you can see, I can just issue standard text commands, but that is what this is doing. So let's try that command. 25, paste. There we go. So we see we get the same response. It's given us some options there for what we want to do. So start TLS, etc. So let's escape out of there. But yeah, essentially, if we issue these same commands here, we're going to get the same sort of response. Now, moving on to authentication. For authentication, as I've said, certificates are used to verify the server is who they claim to be. The email client will use its own certificate repository or that of the operating system, just the same as a browser does to validate that the server is who the server is. So that's the same as HTTPS, browsing, server authentication, it's the same thing. And we can, of course, look at the certificates that are on there. And this is a useful site to do that. So if we click on more detail here, let's have a look down. And there we go, we can see the first certificate in the chain. There's a public key. And the certificate itself. And then the second certificate in the chain. We can see all the way down as to where the root certificate is. Client-side authentication. So depending on the mail client, you'll have different options for authentication. So those include things like transmitting the password unencrypted, which was what was originally done. And then you've got transmitting the password encrypted because you're using SSL or TLS. You can do things like Kerberos or GSS API, which is something generally used for enterprise solutions. You've got NTLM, which is a Microsoft solution if you're connecting to Exchange servers. You could use TLS, SSL, or some type of certificate for your client authentication. There's something called OAuth 2 that you can use, but generally you want to try and use some form of strong authentication or two-factor authentication if you can, and we cover two-factor authentication in its own section.